Crude oil is one of the most important resources in the modern world. It powers transportation, manufacturing, fuels heating and electricity systems, and serves as the raw material for products. Yet the journey of crude oil begins far beneath the surface of the earth, hidden in over millions of years. To turn this through a long channels, it must pass chain of exploration, drilling, transportation, and refining. Crude oil is a naturally occurring liquid made mostly of hydrocarbons, molecules of hydrogen and carbon. It forms over immense spans of time from ancient plants, microorganisms buried under layers of sediment. Different reservoirs produce different types of crude, ranging from light and sweet to heavy and sulfur-rich, and refining light. Oil accumulates in underground reservoirs when geological conditions create a trap. These traps may form in folded rock, faultures, a reef or reservoir must have porous rock to hold the oil and a seal to keep it from escaping upward. Geologists study these structures carefully because like empty ground or openness oceans is the key to may contain to finding hydrological systems far below. Before drilling begins, oil companies must first discover where crude oil may be located. Exploration starts with geolocation sensing and seismic surveys. These surveys send sound waves into the earth and record how they reflect from different layers. Geoscience is possible as traps, and drillingtation is a commercially viable oil, but without exploration, the production process cannot begin. Once a potential reservoir is identified, specialists evaluate whether it can be developed safely and economically. A drilling location must be prepared before operations begin. On land, this may involve building a pad, access roads, storage areas, and support facilities. Offshore, the preparation may installation, subsea equipment installation, water handling and safe machinery and safety systems. Every element must be in place because the operates on continuous controlled activity around the clock. The moment drilling begins is called spudding the well. The drill bit starts cutting through soil and rock, and the hole gradually deepens. Early stages of drilling are carefully controlled because the upper formations are as the well progress, casing will later be inserted to remarks the start of the physical connection between the surface operation and the deep reservoir beneath. As the well encounters different rock layers with varying hardness and pressure, the well deepens. Engineers constantly monitor the drilling rate, torque, weight on bit, and mud properties. To keep the well safe and stable, steel casing is installed inside the drilled hole. Cement is pumped into between the casing and the rock formation, locking the structure in place and laying underground layers from one another. This prevents wanted fluid movement and helps protect grounding formations. Casing and cementing are a suction because they allow the operate safely under high pressure and demanding conditions. When the well approaches the reservoir, specialized tools are used to confirm the presence and characteristics of the oil-bearing zone. Logging instruments measure pressure, resistivity, density, and other properties. These readings help determine whether the target is crude oil and how much productive capacity or water. Reaching the reservoir is a major milestone, but the well still requires completion before production can begin. Well completion prepares the reservoir for controlled production. Engineers install tubing and other equipment, valves that allow fluids to flow safely from the reservoir to the surface. Some reservoirs produce oil naturally because underground pressure pushes the fluid to the surface. Others need artificial lift systems such as gas injection to help bring the crude up. Once production begins, the oil, water, gas, and small solids. The raw stream must be handled carefully because it can change over balancing act. Production is extracting efficiently and protecting the integrity of the well. The produced fluid is sent to separation equipment that divides it into crude oil, natural water. Separators use gravity and pressure differences to isolate the components. The natural may be processed, used on site, or sent to market. Water is treated before materials is essential because refineries that require crude oil that has been conditioned for safe handling and efficient processing. Before the oil is moved off-site, it may undergo treatment and stabilization. This helps reduce gas content, remove additional water, and improve storage safety. Pipelines are one of the most efficient ways to move crude oil over land and in some cases beneath the sea. Pump stations maintain pressure and keep the crude flowing over long distances. Operators monitor flow rate, and pressure around the clock, but it demands constant maintenance and strong safety systems to reduce leaks and continuous operation. The refinery is where crude oil begins its transformation into finished products. When the crude arrives, it is measured, sampled, and stored in feed tanks. Refineries are vast industrial complexes with towers, reactors, pumps, and control systems operating in tightly coordinated sequence. Their purpose is to separate diffractions and convert them into usable fuels and chemical feedstocks. Before crude enters the main processing units, it is pre-treated to remove salt, water, and solid contaminants. This desalter stage protects refinery equipment from corrosion and buildup. It also improves efficiency in downstream processes. Atmospheric distillation is the refinery's first major separation step. The crude oil is heated and introduced into a column where components separate by boiling point. Lighter compounds rise higher in the tower, while heavier ones stay lower. Distillation is the foundation of refining because it divides crude into manageable pieces for further processing. The heavy material left after atmospheric distillation still contains valuable hydrocarbons. Vacuum distillation processes this residue at lower pressure, allowing separation at reduced temperatures. This prevents excessive thermal cracking and preserves more useful feedstock for later resin units. It is a crucial method for maximizing yield from every barrel of crude oil. Heavy fractions break into smaller, valuable molecules through catalytic cracking and hydrocracking, creating gasoline and diesel from heavier oils. Refined streams are then blended into finished products such as gasoline, diesel, jet fuel, lubricants, and heating oil. Additives may be included to improve stability, prevent or enhance engine performance. Blending ensures that every batch meets precise specifications. This is the stage where refinery outputs become the familiar fuels and products used every day. Before products leave the refinery, they undergo rigorous testing. Laboratories check density, viscosity, sulfur content, volatility, flashpoint, and other important properties. Quality control confirms that the products meet regulatory and customer standards, because even small variations critical. This final verifications can affect engines. Every product must pass inspection before distribution. Once approved, the final products are stored in dedicated tanks and sent into distribution networks. Pipelines, rail cars, and ships carry them to airports, service stations, homes, and ports. Final stage of the crude oil journey. This is the material extracted from deep oil underground becomes the energy that powers everyday life. Crude oil's journey from production to refining is one of the great industrial processes of the modern age. It begins with geology, continues through engineering and transportation, and ends as the fuels and materials that sustain. Behind every liter of fuel is decision and discovery to discover the world. Crude oil is a path shaped by science, and like and share your subscribings and powered views in the human effort.